Hey everyone, thanks for coming back and checking out Tilt Tech Pinball here on YouTube. Appreciate you stopping in again. Today we're going to be taking a look at these pop bumper driver boards that are in all System 80 machines. The reason this video series has been moved up a little bit, originally I wasn't planning on doing this quite yet, but the other night we ended up setting fire to Mars God of War as a result of these aging pop bumper driver boards. Another pop bumper coil ended up locking on and filling the hole under glass with smoke. So really at this point in time, out of the 4 pop bumpers that are in God of War, 2 of them have locked on and essentially cooked, causing Mars to be very unplayable. I'm actually afraid to even turn it on at this point in time until we get these things resolved. So today we're going to be taking a look at these and rebuilding, as like a service bulletin a number of years ago from Gottlieb suggests, rebuilding these. We'll also be taking a look at Clay's guide on his suggestions for different components, and also on PinWiki on the System 80 repair guides and tutorials there and what they suggest to repair and replace on these boards. So let me get you set up here and we'll take a look in both, not just God of War, but also in the Night Moves machine as well, because it's also a System 80 machine. We'll take a look at the pop bumper driver boards that are in here and also in God of War, and we'll get started on this. It's definitely something that's long overdue. I'm tired of burning out coils, and I'm definitely tired of nearly setting fire to my machines. So let me get you set up here and we'll take a look inside of these machines. Okay, we're back. We're just going to take a quick tour here. So this is Night Moves, little cocktail pinball machine. It's a Premier game, but it's a System 80 game through and through. It's all System 80 kind of architecture and boards and stuff. So what we're looking at is I got the machine up here, the playfield up on the little prop, which is janky at best. So as soon as we get done talking about the inside of this machine, I'm going to lower this down because the prop is just weak and scares me. So what we're actually looking at here is we got our motherboards over here. There's our MPU and our soundboard and stuff, and light and solenoid driver board there. And on this right hand side where this blank space is here, and you can see the Molex edge connectors there, that's where there's a number of remote mounted transistors and stuff on this board, and on either end of this board used to be, and it used to sit right here, I guess it probably was flipped over, used to be the pop bumper driver boards that we've been discussing. So on either end sat one of these, so something like that. So and inside, so far what I've actually figured out is inside Night Moves, because it was actually one of the very last games in the System 80 series, the Night Moves pop bumper driver boards have already been rebuilt. So that's kind of interesting. So I'm not sure if they were rebuilt by a tech a number of years ago, or if they were actually shipped that way from Gottlieb with the corrections made. So those ones we may actually not rebuild because they look to have already been rebuilt and seems to be functioning just fine. The ones that I'm actually having problems with are the ones that have not been rebuilt as of yet, the ones that are obviously older boards that have never been revised. So here we are taking a look inside of God of War. So playfield is up. Take a look down here. I actually have one just kind of dangling there. So that guy that's dangling there off the end on the left side there, that is actually another one of our pop bumper driver boards. And then if we look up, there's the 2 others right there. So we're going to just take out all of these, put our playfields back down so we don't kind of run into any problems, because I don't really trust the props on this one either, even though they're much more stable. and we're going to get these on the bench, take a look, compare and contrast what the differences are between the ones that seem to have already been rebuilt and the ones that we definitely need to rebuild. And also I have one that's kind of in a middle state of repair where I did some repairs to it in hopes that it was going to fix the problem, but I didn't rebuild the whole thing. So let me get you set up on the tripod here, and we will have a look at some of these boards. And I'm going to remove these 3 boards that are still in God of War here. So one moment. Okay, I just wanted to show you guys some stuff here inside of God of War real quick with regards to these 4 pop bumpers and the pop bumper driver boards that are associated with them. So what we're actually looking at here, along the bottom here, there's 1, 2, 3, 4. The far left and the far right pop bumper driver boards are removed. What I was actually wanting to demonstrate and show is that so each of the pop bumpers themselves actually is assigned to one of these boards. And if we wanted to actually find out, like if you wanted to find out just, you know, you're having problems, let's say with this one, which would be the upper right pop bumper, which is the first one that burnt out on me. So this one here, I want to find out which pop bumper driver board is associated with it so I can repair that one. So I know that that one is fixed and it needs to probably be fixed, you know, straight away. All of them are going to be repaired or rebuilt, but that one most definitely, because this one even cooked the coil, and then this one here, which is the upper left one, is the one that was cooked a couple of nights ago. Ended up frying the coil here. So these are the 2 that absolutely have to be repaired straight away and new coils put in. So let's, I just want to show you how to find out which pop bumper driver board is associated with which coil. So on the right hand side here, this right hand coil lug, on mine it is a purple red, and on each of the plug-ins, the connectors for the pop bumper driver boards, just to the one side of the green wire. So right here we have the green ground wire, and it's pretty close to one side or the other depending on which kind of way you're looking at the connector. The wire on the very far left or very far right, depending on how you're looking at it, is the wire associated with the pop bumper itself. So what I want to do is check continuity between here and there. So I'm going to put my probe, one of my leads on this, which looks to be the correct one, orange, red, and then, so we know purple, red, which goes right here on this far right-hand driver board. We know that that one was associated with this pop bumper that ended up failing. So that one definitely needs to be rebuilt. I'm actually going to mark these even. I think it would be a very good idea. So in this location here, I'm going to put, top right. So let's put TR, top right. And the other one here that I actually have removed, let's just test it real quick. So the wire to the one side of the green ground wire is this, looks like brown gray, or maybe orange gray. I'm going to put one probe on there, and let's see where so he goes to this one. So the driver board that came off of this, which is actually right here, I just laid it in the bottom of the cabinet. This one is a pop bumper that we're actually not having any kind of issues with. This one functions just fine. Have had no problems with it locking on or anything, but it needs to be rebuilt. But the interesting thing about that is that this one, the pop bumper associated with this coil that's been acting just fine, is one of the pop bumpers, because I've kind of played like musical chairs here with the pop bumpers or driver boards that are in God of War and the ones that came out of Night Moves. And this is actually one of the ones that's actually repaired. It's one of the ones that either came from the factory this way, or a tech back in the 80s ended up rebuilding it per the service manual, or the service bulletin. That's what I'm trying to say. So this one's actually good. And the pop bumper that's associated with it is acting just fine. But this one actually came out of Night Moves. So I'm actually going to put this one just back in Night Moves, probably as is, without any kind of new repairs to it or rebuilding. And as far as these other ones, I wanted to actually mark. So this is the lower left. So I'm going to actually put LL here, because the pop bumper driver board that goes in this location plugged into this circuit here goes to this lower left pop bumper driver board. So that'll always be in that location. So let's go to the bench here and take a look at some more stuff and start actually getting things repaired and replaced. One moment. Okay, everyone, we're here at the bench taking a look at some of our components and how we're going to set off kind of doing this. So I wanted to show you this one. I actually familiarized myself with the process last night, and thankfully so, because it's actually not the easiest of processes, I suppose. So this one is actually 100% fully rebuilt. Sorry about the lighting over here. Maybe that's a little bit, no. Whatever. I think we're just going to have to be here. So the components are completely rebuilt on this one. And so there's a few things. There was a service bulletin back in the early 80s, whenever the System 80 machines were coming out and stuff. And they mentioned, just in that service bulletin, Gottlieb mentioned to just do two things. And those two things are essentially, and pay no attention to this because this was my own modification. The two things that were mentioned is to change the polarity of this capacitor there, and to remove this diode here. And that's it. That's all they mentioned to change. But then there's been other people that have come along and have decided to make a number of changes for reliability's sake, but also to make the pop bumpers more powerful. So there's a number of things that we can do. We can actually change a lot of the components to newer and better components, or we can change some components to make the pop bumpers more lively and more poppy. So there's so many write-ups on this, it's kind of hard to digest what it is that you need to do and how to go about it and with what components. So I've done a lot of research, found out that Big Daddy, this guy here, sells Gottlieb pop bumper driver board repair kit, and this is ×5. So this is he basically puts this kit together. If you order 4, he'll give you a 5th one for free. So being that I have 6 driver boards that are in need of repair, or at least I thought until I found out that a couple of the ones that are in Night Moves have already had the repairs done, I ordered this thinking that I was going to be repairing about 6 of them. But this was a good way to get me started. So what came in this was what's in the bag still, which are our sockets for our IC chips, and also all of the parts inside here. There's some caps there. There's some more electrolytic caps here. And I think my one of our resistors are in there, and also our diodes as well. Let me get you, see if we can get some better light on the subject. There we go, much better. So we got our Little tiny diodes there. Two different capacitors. That one there. 47 microfarad. And I believe it's a 16 volt. And this one does have a polarity to it, as marked by our little negative symbol along this gray band there. That's actually the symbol for negative, so this lead here on this side is actually our negative lead. And then we also have another one here. This is a 1 microfarad cap, and it's a what is the voltage on it? 50 volt. There it is. And then we also have some resistors that came in this rebuild kit right here. So everything that Big Daddy sends is actually a rebuild for the entire pop bumper driver board. So you get everything. Every component is actually replaced. Even though when Gottlieb sent out the service bulletin, they only recommended switching the polarity of one piece and removing another piece. But since then, Clay has come out, and if you remember, I mentioned that Clay is kind of a Gottlieb guru from back in the day, wrote some fantastic articles on how to repair and replace and redo everything inside of a Gottlieb machine and just dissected it. So a huge resource. A lot of his stuff is kind of hard to find nowadays. He's definitely put it kind of under lock and key, and would definitely appreciate your support of him if you're going to be using his materials. But Big Daddy has their kit replaces everything, and it's per Clay's guide, which is actually right here. And Big Daddy actually has this on their website, a link to Clay's guide. So it's got all this information here underneath, a little picture and stuff. Here's your old board. Oh no, this is actually a board that's been redone already, because you can see there's that little wire there, which was where a component once was, a diode. And so this is actually a redone board already. And then this is kind of the breakdown as to what actually needs to be done with what components at what places on the boards. So this one I've already rebuilt. It's all fully functional. I'm just going to take you back out the tripod again because the lighting is terrible over there. This one's already been rebuilt. I just rebuilt this one last night. You can see the removal of the diode here, and the polarity of this capacitor here has been changed. You can see on the bottom side there that there's a beveled end. It's not kind of squared off, it's kind of tapered, kind of to a cone shape. And that determines the polarity. And here's an unmodified board, and you can see the black capacitor in the same position as this yellow one here. The coned and tapered side is this upper side, and that is actually what they're suggesting, that you move the polarity, so turning it 180 degrees, so the tapered coned end, which I'm assuming is the negative end, is actually pointing downward. Actually, nope, that is the positive end. So that's how you know which is the positive end. So the positive end on this one is actually pointing upward, and it needs to be reversed, so it's pointing downward. And then this diode below it, this little kind of translucent orange one, just needs to be removed in its entirety. So that is that. And as I was mentioning inside of Night Moves, these ones have already been redone. So this is actually Night Moves pop bumper driver boards as I own them currently, without any kind of repairs done to them, no components replaced. This one is fully functional, has never locked on, never had any problems. As you can see, the capacitor is tapered towards the bottom here, which is correct. So the positive end is facing downward, and it already has this component removed, or never had it to begin with. So that one is all good. And another nice thing too about this is the thing that I mentioned about making the pop bumpers more lively. You can actually do by changing this cap out here and this cap up here, this larger yellow one. If you change those out to different values, oh, I'm sorry, it's not actually this one. This one is the same, but by changing this capacitor here and this resistor to different values than what's previously on the board, makes the pop bumpers a bit more lively and aggressive. So whenever I redid this one, I redid everything. So this one's completely rebuilt and has the new resistor for the poppier, livelier feel, and the new cap for livelier play as well. So, and I'm just going to show you how to do all of it as well. So we're going to do all of those modifications to this board here. So whenever things started locking on, I actually read on PinWiki that you can actually just, because of the difficulty in finding these big transistors, you can actually replace those transistors if you start to have problems and you suspect the transistor is the problem. You can replace them with these TIP, what are they, 102s? Yeah, TIP 102s. There he is. And that didn't help. So, I mean, it helped. It didn't help, I guess. I thought it was going to fix the problem, but then it ended up locking on. And this is one of the ones that ended up causing the coils to burn out. So this one is definitely need a full refurbishing. So let me put you in the tripod here and see if I can get you some better lighting. And we will take a look at the rebuild process of this particular driver board. One moment. Okay, so we're just going to jump in here and start removing a bunch of these components because we already have it kind of figured out what components kind of go where. Everything that I am doing, I am referring back to Clay's guide here, which I got off of Big Daddy. And the component kit is from Big Daddy as well, and he just has a link right below where you can order the kit. You can either order them individually or in a 5-pack like I did. And so we're just going to jump in here. I'm going to remove this transistor here first, and we'll get this new big bottle cap transistor that's supposed to be there back in its place, which we have plenty of right here. It came in this kit. I got my little solder pullet, little solder sucker. Let's see here. Not really a fan of this little solder sucker. It gets clogged very easily. But we're just heating up the solder joints here and immediately putting our solder sucker on there and pushing the button and sucking up all of the loose solder that we can, all of the liquefied solder. And we will see if we can bend the legs up on these. So I'm not really sure I would recommend this TIP 102 modification because it didn't seem to work for me, and I just ended up burning out my pop bumper coils anyways. So myself, I would not recommend going down that route. So you're welcome to try it, but it did not work for me. So I'm just going to cut this other leg off here on this one, and we'll be able to remove the leg right there, get him out of the way without burning down too much of my stuff. So with this, we're going to, on these, the transistor, the legs are actually on one side or the other are actually higher. So like right here, they're actually above center. So you can kind of make out where they're supposed to go on the board. So this one, the legs are a little bit higher here, and the holes are a little bit higher than center here. So it goes in like that, and as you can see, the holes for the screws are in line as well with everything as it should be. So I'm just going to bend these leads down a little bit. I always like to bend them down the traces that the electrical traces kind of go towards. So if you can't get all of the little legs cut off, at least the traces or the legs are actually on the traces that they're supposed to be sending the electricity through anyways. So it makes sense to bend them in the same direction. So we're just going to solder this guy down here real fast. There's that. There's that. There we go. I'm going to leave the legs all on for right now because I want to make sure everything is in its proper place. So we'll check everything over, check our work afterwards, make sure everything's in its proper location before removing the legs. Because once you take the legs off, it's really difficult to work with them in case they end up having to go in a different location. So I think now, really one of the biggest bears is removing all of these little tiny legs. I think these are 16 legs per chip. So there's a lot to remove, these little teeny tiny legs off of here. So you just heat it up, throw your solder sucker on there, and kind of have to work quickly or else the solder will end up hardening again and you end up not being able to get anything up as a result of it. And sometimes the solder on these is actually so old that it doesn't really want to flow any longer. So you could actually, I know it's actually more to kind of suck up, but you can actually just give a little blip of solder on each of the pads. And even though there's more solder now to suck up, it actually sucks up better because it's flowing a lot better. Much easier to suck up. We don't really have to be too cautious about accidentally overheating any of these components because all these components are going away. So every one of them is coming off of the board and is just going to the trash bin. So no real concern with trying to salvage any of this. Hope you guys can all see. I'm just going down these 8 here and 8 more on the other side. We're just going to work out this one chip and then we'll move over to the next chip. And putting some more solder on there was definitely the way to go because it makes it a lot easier to suck this up with new solder. And you got to put your little solder sucker on there fairly flat, or else it won't get any kind of real suction to it. Let's see if we can wiggle this thing up at all. We should have some of them freed up a bit. So what I'm going to do is slide this down on this side and heat up from the other side. I don't know. So I'm going to start at the top here where my screwdriver is actually on the other side, and I'm just kind of gently prying things up as I heat up each of the traces going down. And you can see it kind of, and feel it for certain, kind of giving way as the everything starts to pull free. So let's flip it over and kind of run our screwdriver down the other side and see. So these definitely take some working out. The holes are just so small that the solder sucker does its, as good a job as it can, but I do wonder if there's just a way to clip these legs off. Let me get it off of here and I'll be right back. Okay, we're back. I got that chip off. So there it is, or there it was. We're going to be putting a socket in that place. So if we ever have to remove these chips again, we can just pull them out of the socket and the socket will just stay in place. Keep in mind whenever you're using messing with these integrated circuits that they have a position where it determines where pin 1 is at. Basically on these, if you have your connector on this left-hand side, like I do, the little notch here at the bottom indicates where pin 1 starts. And I'm not sure actually which way it goes. I think it goes 1, 2, 3, 8, and then 9 through 16 there. I could be wrong about that. But you just want to orient everything the exact same way that it came off. And on these, if you can see, they have a notch at both ends, but one of the notches is actually a bit more distinct, and it has a bigger cutout on this bottom notch here. So we're going to orient that towards the bottom. Not that that really matters as far as the socket goes, but at least you'll know if you remove the chip later that the socket is indicating to you that the notch needs to be at the bottom, because the notch on the socket is at the bottom. So let's flip this over, and I'm going to set something here underneath it. I'll just set this screwdriver here underneath it to kind of keep it pressed upward so the pins don't end up falling out. And we'll just tack it down real quick with a couple of pins on either side so it doesn't go anywhere. There's that. And that. So then we'll just go back through and do the rest as well. So, and on these chips you want to be kind of quick so you don't put too much heat to them for too long. So okay, those are all tacked down now. And then we can just place our new chip in that location. As for this other one, I'm not really sure what I want to do, because that was kind of a bear. I mean, it wasn't any easier for me to do it last night by myself either whenever I did this one. But let's see. Oh, actually, you don't have to be very quick in installing the new ones, because that's actually just the socket. And the socket is a lot more durable than the chip itself. So whenever we tack down that socket, it doesn't really matter. Excellent. Okay, I guess we're just going to take off and go down this other chip. All the other components that are on this board are going to go a lot faster than these two chips. So once we get these two chips out of the way, we should be flying along. I'm actually going to add a little bit of solder to all 16 of these just real fast, because it helped a lot on the last one with sucking them up. And do be real careful with these little trace pads here, because you can lift the trace off, essentially destroying its connectivity to the electrical path of travel to the next component on the board. So you just have to be, well, very careful not to do just that. Okay, solder sucker here again. Heat it up. Solder sucker on. Push the button. And kind of at the same time trying to get our pins straight up and down as well will help us out a lot. This one may go a little bit better than the last. At least it's feeling that way. Everything seems to suck up pretty good. I do think a lot of it was because of adding the new solder to these pads. There's so little space between each of these traces It is very difficult to get the end of the solder sucker in there. It's just slightly too big to be able to fit between one pin to the next. So we got to do what we can. Try and get it down on there as close to flush as possible. Yeah, this is going pretty smooth. I have a feeling this one's going to come out pretty easily. I've got to actually get a desoldering iron. Sorry about that. Dogs went crazy barking at the mailman. Didn't miss anything. I just stopped and then restarted here. The chip is, all 16 of these are desoldered. Let's see if we can wiggle him out. Just keep looking back and forth at the back side with all of the solder traces on it, to make sure you're not doing any kind of damage to the solder traces. There we go. So that one was so much easier. You actually watched me do the entire thing. Just be really careful about getting those pins to stand straight up and down, and also getting as much solder off of there as possible. So let's put in another one of these sockets with the bigger notch pointing downward. There's that. We're going to stick the screwdriver back behind it here to kind of hold it off of the, to keep it pressed in, which it's having a tough time doing. Here, let's put it on this end of this screwdriver. We just need to put one or two little just get a couple of the pins tacked down, and now that there's one on each side at either end held down, the socket won't go anywhere now. So now we can get the little wonky screwdriver out from underneath there. Okay. So let's just reattach the socket. There we go. Just quickly double checking to make sure that there's no little solder globs that are coming in contact with anything or bridging the gap between anything. We can also take our multimeter and check continuity on each of the adjacent pins and make sure nothing's touching that shouldn't be touching, or connecting that isn't supposed to be connected. Let's take a look here at our So what we just did was replace this Z1 and Z2. And if we refer down to here, Z1, let's just go with Z1. Z1 is supposed to be a 74-121. And Z1 is the one to the rightmost here. And let's see. So there's our 16, which goes in the other socket. That's a 16 also. Here we are. 74121. I don't know if you can see that or not, but that's what it says. It says DM74121N. So I'm just going to quickly, so Z1 74121, and that's in this right hand side, notches towards the bottom. And making sure all of the legs go into a hole here. You kind of have to give them a kind of a press inward sometimes. And make sure no little legs are sticking out the edges or anything. Make sure all of the legs went into a hole. We'll stick this other one in here real quick. Everything seems to be sliding into a hole. Push it down in there. Double check that any legs are not hanging out. I think we're good. We now have socketed IC chips. And I don't really know what it means. I understand caps and electrolytic caps and resistors and how that all kind of works, but I'm not really sure what Z1 74121 one-shot multi-vibrator is all about, nor do I understand what the Z2 IC chip is of SN7416 hex buffer. I'm not sure what those really do, but they belong on these boards and need to be updated along with all the other components. So most likely those were not actually problematic, but I have the components to do it anyways. And being that I'm not going to do the ones inside of night moves, I'm going to have some left over. So if I ever encounter any kind of problems down the road, I should have a couple of each of those chips left over from doing all the ones inside of God of War. So let's move on to the next couple of components. Let's replace this cap here. So on our guide here, that cap, if we're looking at the guide here, that cap is the one down in the bottom left, which is C4. So we're going to look here at C4, and it says a 47 UF electrolytic capacitor. The negative terminal must be pointed towards the... it just says with stripe and must be installed as shown. So basically, the left side negative here, so the little stripe that indicates negative on this C4 cap needs to be pointed to the left. So, and that cap is this bluish one that comes in the Big Daddy repair kit. And it has, on one side, it has this grayish band with little negative symbols in it indicating which side is which. So that's what we're going to be replacing right here. So we're going to flip this over and we're going to solder suck this cap off of here. think I'm going to add a bit of solder because it's really just not wanting to pick up like it should. Plus my solder sucker is just getting kind of clogged. But putting on new fresh solder that isn't 40 years old does tend to help a little bit. So. Oh yeah. And I think I'm going to have to unclog my solder sucker real quick. Be right back. Okay, we're unclogged. Really, this thing clogs up way too easily. So I will definitely be investing in something new before too long. So I ended up solder sucking both of these pads. I think I need to do this one more time. Make sure it gets all cleaned out. Okay. We're going to lift this leg off of here. That one's fully so this leg's bent down pretty aggressively. I just need to get under it while having the heat on it and lift it up a bit. There we go. May as well do the same to the other side here as well. Just don't damage the traces. Really, I guess I could have just held on this side and kind of wiggled this downward while... That's probably what I should have done. While heating up both of these. And there we go. So maybe that was the better approach to it. Our new one's going to go in with the negative side, this little gray band that has a little negative symbol. It's going to go here to pointing to the left. So it goes in just like that. We're going to bend these leads down kind of in the direction of the pads that they are associated with, the traces that they're associated with, in the direction of those lines. And tack this back down. And these leads are actually pretty close together, so do be careful to not bridge the two trace pads between the two, the negative and the positive side of that. Let's work on the other cap that's here. So this cap over here originally was a metal cap, a polymetal cap. Both of these little blue caps here up in this top right corner are polymetal caps. And this is one of the components, this leftmost blue polymetal cap is recommended to replace that not with another polymetal cap, but with actually a electrolytic cap and this resistor here on the right side of those as well to give the pop bumpers more more pop. So I think we are going to, and I think I'm going to try it this way, where I'm just going to grab this and kind of give a little bit of a wiggle from the one side while applying heat to this side. And then we can remove the, yeah, that came out super easy. Looks like I may have left a leg behind though. So heat that up, pull the leg out. The electrolytic cap that we're actually putting in that location is actually not polarized, so there's no positive or negative on the cap determining orientation. So it can go in either way. So let's just heat this up so we can get our old solder off of here and have a nice clean new trace to put our new cap in. Okay, so our new cap is these little black ones here, and on our guide up here, this is going to be cap C1, and it's a 1 microfarad, and this one's a 50 volt cap, non-polarized. So we're going to place that in here like so. No need to observe polarity because there is no polarity. Bend the leads down in the direction of the trace pads that they're associated with, and we're going to just quickly tack it back in place and move on to the next component. So that goes there. And that goes there. I think before too long I'm going to need to invest in a new solder tip. This one's getting very tarnished. Okay, so let's replace the polymetal cap, this blue one here, as well while we're in the same area, and also the resistor that's next to it there as well. So I'm going to heat up the component from the back side here, the legs on the back side, and give it a wiggle with my pliers and pull this one free. Oh, I lost a leg on that one again too. There we go. So that one's out. If I can get the leg off. Let's come in here and clean up the traces here, the pads, solder pads on each of these. There we go. The polymetal cap, these do not have polarity either, so you can put them in either direction. So going back to the top of the board here, up in this, let's try and keep this oriented the same way each time. We're going to slide this back into its new home. Again, bending the legs down so they kind of orient towards where they need to end up. There we go. We'll tack that down real quick and on to the next component. Wonderful. Okay. I'm just going to replace this resistor up here in the top right as well. So the resistor that was there, well, they don't actually mention what the old resistor was, at least here on Clay's guide. I could look it up easily enough. But it's a position R1. And R1 is saying to replace with a 10K resistor. I believe actually it was a 1 ohm resistor. And now they're suggesting that it be a 10 ohm resistor for, well, let me just double check that that is correct. I have it right here. So there is an update to the pop armor driver board that gives the board a bit more pop. Simply replace resistor R1, which is actually a 1.5 ohm resistor, with a 10 ohm 1/4 watt resistor, and replace C1, cap C1, which is a 0.01 microfarad capacitor, with a 1 microfarad 100 volt non-polarized capacitor. So that's what we did with this guy here. This is C1, so we replace that and hopefully get some more pop out of it as well. So I'm really looking forward to seeing how much of a difference that actually makes. We'll have to check it out here shortly. So I do have the new one, the new resistor. It's these little blue guys here. This little guy here. And he is a 10 ohm resistor. So to make this easy, I'm actually going to try and just snip. And I wish I had some smaller little wire cutters. These are my big guys for work, wire cutters. So I snipped him off, and now all we have to do is just get the legs out of there and then clean up the solder pads on there. See if I can. It's really close to this little standoff here. It's kind of difficult. I don't really like using this like little screwdriver next to the pads, the solder pads, because it just seems like it could cause some problems. I just don't want to scratch one of the solder pads and end up ruining it. So that's out of there. Now for the next one right here. There we go. Let's put our solder sucker on there, get some of this old crappy solder out of the way here. So with the resistors, and I don't want to generalize, but I don't think most resistors have polarity. Whereas a lot of capacitors, it's depends on the capacitor whether or not it has polarity. Most resistors, to my knowledge, do not have a polarity. So the new resistor, we're just going to do a little pre-bend here. Looks about right. And in it goes. Okay. It's all looking pretty legit. Bend those down in the direction that the traces are all headed. Let's just tack that down real quick. We only have a couple more resistors to go and we'll actually be finished here. Sorry about my squeaky seat. It makes all sorts of noise whenever I move around. Okay, what component are we going to remove next? So let's do this one here. This was actually part of the service bulletin. We're going to remove this capacitor here and change the polarity to go the other direction. So positive will now be at the bottom end here, and then we'll also remove this diode there as well and put in just a jumper wire. And most likely we'll just use like one of the longer trim off one of the legs off of one of these components off the back here and use it as a jumper to go from here to here. So let's see what we can do about this. I think I'm going to try and grab hold of the component on this side, this cap here. Hold on to it firmly and desolder it and wiggle it from the other side. Well, I got one side out. And the other side. Sorry about the abrupt break there in the video. We're back. We're installing this cap here. It's a tantalum cap, and it has the tapered end here, which is the positive side. And on our board, the positive side is going to be facing downward. So we're going to give this a little bit of a bend here. Looks good. Put it in our board here. Make sure it's all nice and seated there. Okay. Bend the legs out of the way. Okay. And let's tack it down real quick. Okay, so now that we have this cap in place and it's got the correct polarity now going, this is one of the service bulletin mods where the polarity was once pointing upward, the positive was at the other end here, and this diode here below it needs to be cut off. So we're actually going to cut that off right now. And I may not be able to. We may actually have to just grab it and pull it out whenever we apply some heat here. Well, I ended up just crushing it. So now I got a bit more to grab onto now that the leads are now sticking out. So apply some heat, and there's one leg off, and the other side should be able to grab it here. And that's out. So this is the one that we're actually not replacing. It's actually just going to be removed. And we're just going to put in a jumper wire in its place. We still need to clean up the pads to ensure that that jumper wire can go through the holes here. Excellent. So we got a couple of longer wires here, and some of them are a bit more solid than others. So I like this one here because it's a bit more rigid of a wire. So I'm going to just snip this one off, and hopefully it's long enough to serve as our jumper wire. So I'm just going to bend up both sides here. And put this back through our holes. Just like that. Oh, that worked out beautifully. So our jumper wire is now in place. We can bend the ends of this down a little bit to keep it in place while we tack it down. Okay. Excellent. So now all that we have left is these two resistors and this one diode here. The only thing that needs to be polarity observed is this diode does have polarity. So there's a banded end, and I'm not sure if it's the negative or the positive, but there's a banded end, has a little black band, and the rest of it's kind of this translucent clear orange, and then a black band at one end. That black band needs to be facing upward here on our board. So this one, I think I do have enough room that I can just clip off the legs. So I clipped one of the legs off, and I'm going to grab the rest of it here with my needle nose and work it out while applying heat to the other side. So there's that. And now I just need to go fishing for the leg here. So I get a hold of the leg and apply heat to the other side and pull it through. Okay. So we need to clean up that section there, our two solder pads there. These ones look really kind of oxidized and corroded, so I'm actually going to put some new solder here to mix with the old. See if that helps with removing the old solder here and clearing up the pads. Okay. So everything's cleaned up now. We got our new diode here, banded end towards the top. Give it a little bit of a bend on both ends here. Like so. Banded in towards the top. You should be good. Just hold them in place while I bend the legs down. Okay, just tack them in there. That's that. Okay, 2 resistors left. Let's snip. You know what? I'm just going to snip both of these right now. So lift him up. Lift him up. Grab one of them here. And make sure you're undoing the correct pad. Grab the other one here. Pull him through. And then we just need to see if we can grab hold of these tiny little legs here. One down. Grab the other one. And he's gone. Okay. So now all of our old components are actually removed from the PCB. So all we really have left is to put the new components in. Let's I'm going to dab a little bit of new solder on each of these to kind of freshen everything up. And let's solder suck it off of here. So that one's all cleaned up. Okay, we now have our holes cleared out. We're going to be putting in a, what is that, red, brown resistor, which is a 220 ohm red, brown into R3 position, which is actually underneath this diode that we just replaced. And again, no polarity on these, so we can just put them in whichever way you feel like doing so. And the legs out of the way. I'm going to put the other one in here as well, which is the R2 resistor, which is a 12 ohm resistor. If I can find him, he's right here. Okay, and this 12 ohm is a brown, red, orange. Okay, so that's in there. Let's bend the legs out a little bit to hold them in place. We'll just tack down all four of these in one shot, both ends of these resistors, and we will be done. We'll just double check our work. So we'll double check our work, and then we'll snip off the legs. Okay. So we got our diode here with the banded end pointing up. We got our tantalum capacitor here with the conical end pointing towards the bottom, which is the plus side, so that's now facing downward. We have this diode here removed and replaced with a jumper. We have our red, brown resistor here on this left side, close to our transistor here. We have the next resistor over, which is our brown, red, orange here in the middle between this resistor and our jumper. We have our new IC sockets and chips in place. We have our capacitor up here for some better pop action on our pop bumpers. There is a non-polarized cap that is a 1 microfarad non-polarized. Then we have our polymetal cap here next to it, which is just kind of a 1-to-1 replacement, which was what was already on there. We have this resistor here on the right hand side that went from, what was it? Was it like a 0.1 ohm resistor to a 10 ohm resistor, I want to say. Is that correct? But this is also one of the components that gives our pop bumpers a bit more pop. And we have our transistor here, and then we have this capacitor here, which is it is polarized, and negative is over here towards our connector. And that one there was what, a 4 point, nope, that was the, what is he? He is C4. Oh, 47 microfarad tantalum cap. Nope, electrolytic cap. Sorry, the tantalum is this yellow one here in the middle. Okay, and that's all of our components. So, guess I'm going to take a quick look here on the back side, make sure nothing is connected to anything it shouldn't be. Make sure I don't have any cold solder joints. I do have to dig out the screws and nuts that went to the cap here to hold that in place, and find where those went whenever I replaced it with that TIP 102 transistor that didn't really, well, not sure if it didn't work or if things were already kind of too far gone at that point in time. Another component or something was causing problems, and the TIP 102 wasn't able to make any kind of a difference and just ended up. So it may have actually worked just fine. It may have actually been another component that was the problem child. So I need to get some smaller side cutters for more detailed work like this. These work all right, but you kind of have to be careful with them, or, well, they just leave kind of a bit too much leg sometimes. But the components on this board are not very close together, so if there's a little bit of an excess leg sticking out, it's not like it's going to be touching anything that it shouldn't be. So should not be a problem. Well, everything looks pretty good here. Okay, everything is removed. I do have to get the bolts in for these, the nuts and bolts, because this is actually like a grounding trace here that actually holds the actual cap itself of the transistor down and grounds everything at the same time. Maybe that's the collector, I'm not sure. But either way, it goes to this pin here on the far side of our connector. So definitely is rather important. So let me find that, be right back. Okay everyone, we're back. It's actually been a few days since we last cut away. I cut away and then kind of things got away from me, and well, now we're back. So I think the last time I was reviewing the video, and the last time we were looking at the pop bumper driver board here, and I think I was looking for the nuts that go on here to secure this big transistor to the driver board itself. So found those, and they're all in now and ready to go back into the machine. And then I did notice that there was a little bit of misinformation that I gave earlier when we were looking in the machine, and that is with trying to distinguish which of the 4 pop bumper driver boards is associated with which of the 4 pop bumpers. And I was saying, you know, to get out your multimeter and check continuity between one of the wires on the pop bumper driver board Molex connector here, and the lugs on the pop bumper solenoids themselves on the magnetic coil there. I got to thinking about it. So if I put my meter on this lug here, or I'm sorry, on this connector here, on this purple red, and I put my meter on here, we get the beep sound saying that there's continuity between this wire and this guy here. But if you put it on the other side, you also get continuity because it goes through the coil and then is apparent on the other side as well. So there's continuity through the coil. But I guess as a visual inspection, if you really want to find out, maybe continuity is not the best way to do it, and you should actually, the wire on the far end, on one of the far ends here, just next to the green ground wire, is going to be the wire that's associated with the non-banded side of the lug here on your pop bumper itself on the coil. So this one here, the wire to the far left or right next to the green ground wire is, on this one it is purple red. Here's purple red. On this one it's almost all gray. It's just a gray wire. And right here on this one we have gray. On this pop bumper driver board, wire here on the far left next to the ground wire is gray yellow. I have gray yellow right here. And then on this one I have gray brown. And right here, this right-handed lug is gray brown. So I think a visual inspection and just kind of color matching the color codes on the wires is a better way to determine which pop bumper driver board goes to which pop bumper. So moving on. So this is all rebuilt. As you can see, I've got a couple of them now that are fully rebuilt. We do have to replace the coil that's associated with these. These two, I'm sorry, not these two, this one and this one, the coils locked on, burnt up, and melted. So we're actually going to be replacing this coil here, putting in one of our new pop bumper driver boards, and then testing it out and making sure everything is working the way it should. So we do have a new coil here to replace this one. This is a 1496, same as what's actually in here. And we're going to get our soldering iron plugged in over here at the in the machine, and desolder that. So let me set this down here in the cabinet. I already had it heating up on the bench over here, and we should be good to go pretty immediately here. So I'm just going to take off the wire here. Maybe it's not gotten quite hot enough yet. So this coil here is completely ruined. Locked on, melted completely, and this is actually not the one that I was playing at the time that it burnt out. That was one of this one here that caused the entire underplay field, or under glass, to fill up with smoke and scare the hell out of me. It's kind of a good idea sometimes. A lot of people suggest, and I've done it myself, to stick a towel in the bottom of the cabinet. So if anything does fall, it doesn't wind up in some other mech and unable to find it. So you can drape a towel over everything here in the bottom. So if something does fall, you can much more easily find it and retrieve it, and it doesn't go underneath your bottom board there. So let's need to get my sockets. One moment. Okay, so I got my sockets here. We're going to take this nut off here. One on the other side as well. And then this should just wiggle off. Just like that. So, we got a very burnt out coil. If you can see here, it won't even suck down. Like, even if I press it down, it only goes down like a millimeter or two. So the coil is just completely fried. So, sorry, I just gave you a kick there. And so we're going to take this off here. Little bracket that holds the coil on there. And so everything should just pull apart now. There we go. So that's the bracket that actually holds everything to the machine, and then everything that holds this to the coil. So, slide that out, and, well, I guess it didn't lock on so bad that it melted the inside, but it definitely made it so there's now a ridge of some sort in there. I don't know if you can see that or not, but you can see kind of a burnt ridge in there. But it does not allow the coil to pull in at all. So, definitely needs a new one here. So the new ones, for some reason, did not come with the diode band on here, or the diode on here. So this one, if we look at it from this direction, the band is on our left. So we're going to do solder a new one together. Here's the new one, and there's no diode on here. So we'll put the new diode on. Let me find the diode real quick. We'll throw that in there. The diode that you'll be using, if it doesn't come with a diode already, is a 4004 diode. And just so happens I have a long strip of them here. They are very common. If you do have a place that does sell electronics in your area, Radio Shack, they should definitely have some there. They're some of the most common diodes out there. So, guess we'll drop them in there, wrap a leg around or two. Like so. Drop the other side in there into the holes here. I don't know why you didn't put the diode on here. This is from Pinball Resource. Maybe you thought I was putting it into an EM, electromechanical pinball machine, and I believe you don't have the diode. You don't use the diode when dealing with those. So there's that. I don't know if you can see, but there is the banded end is on the left. There's a little gray band on the left side there. Maybe you can see it there. And we're just going to tack that down real quick. I'm going to do it off camera here, just in the bottom of the cabinet. Just so we can move along a bit quicker. You guys have seen me solder a lot of stuff during this video, so you missing the quick little solder dab is not going to kill anybody. So there he is, all soldered back on. So we're just going to put him back in the mech here, just the same way it came out. So there's that. Let's see, how did this all go together? Luckily, we have 3 more here in the back box, or under the play field here, to kind of help us out. So there's our, and this will go in. So that's that. This goes in like this, like that, and this kind of slides into the bottom like that. Yep. So everything goes together just like this. If you can compare it to the other one, this one freely slides there. And so we'll flip it over. So that's him there. We just need to snug everything up here with these screws on the back that we took out that hold this bracket on the inside of the big bracket that holds the plunger all in place. You want to try and squeeze everything together as tightly as you can so there is no play in it. Because if there is play in any of this, the pops will not be as lively. So it's a good idea when putting these screws in to squeeze everything together. So I got a firm grip on everything here, pressing everything together with my left hand while putting in these screws. So everything is held firmly in place. And I'm even going to tighten down the screws while still keeping a very firm clench on this. Where's my screwdriver? And we'll, okay. So while still squeezing everything together, okay, so that's all held in there really tightly. The coil is what you want to kind of double check to make sure it doesn't have any kind of real wiggle room. So the only thing that has any kind of movement or room to move around is this. So, and make sure on these that you don't accidentally put this little kind of plastic piece here. It's like a Bakelite kind of a plastic piece here on the other side, like flipped 180, because then it'll be slamming against this metal piece. So you want to have it metal on metal as the stopper for the plunger here. So, okay. So we got our diode on. Definitely remember that. Exceptionally important, having that diode in place. This is all going to go back on here. The way this scores, so this switch moves to, wow, that is really gross. That's going to have to come apart. That is just dirty. There's all sorts of oil and crap underneath that spoon switch. Look at that. that all came off. Not on my thumb, I don't think, maybe, but that. Here, I'll give it another wipe. There's all sorts of grease under there. Wow. Okay, well, one more thing to kind of quickly take care of. So we're just going to remove this switch stack here that contains that spoon switch, and we're going to clean that up real quick because that is just nasty. What I was going to say though is the other switch that's on top of the spoon switch needs to go on top of that little bakelite piece that we were just discussing, and that determines the scoring for the pop bumper. So anytime the pop bumper fires, it'll, when it closes, it'll actually close and cause that second switch to close as well, and that's how it knows to register points for the pop bumper hits. Okay. I'm not going to desolder the switches from their wires or anything here. I just want to, my goodness. Can you guys see that? It is dirty. So dirty. Well, I've been wanting to give this machine a thorough tear down and cleaning anyways, so even more reason to do so. So before too much longer, once I get everything back working again, we will just tear it apart completely and give it a thorough cleaning. So let me find my simple green here or something like that. Actually, I'll just do this real quick. I have some of these alcohol pads. I'm just going to use a couple of these just because they're quick and easy. And this video has already gone on for so long. Look at that. Unbelievable. And don't forget to clean the nub that comes out of the bottom of the pop bumper here, because it'll just reapply all that nasty oil and grease to your. Somebody had to have, at some point, the previous owner had to have, thought, hey, this isn't registering well enough. Let me spray something on here to slick things up a bit. And now we just have a gooped up puddle of KY jelly or something in here. Some sort of nasty lube. No, probably WD-40. Somebody probably sprayed some WD-40 in here to see that the pop bumpers registered better. There we go. There's not many things that you actually could use, and definitely none that you probably should use to do something similar to this, because almost any kind of product is going to leave some sort of a residue. Like in the past, whenever I got, kind of new into pinball, I had the idea, I was like, man, I should take those off and put some wax on those so they slide and glide a bit better. But then over time, the wax would just cause it to gunk up as well. So I don't think there's really a good solution. I mean, they're just meant to be very smooth, polished, metal surface, and nothing more. And then on just the plastic itself, I'm sure is plenty slick. So as long as everything's nice and clean, there shouldn't be a need to have any kind of lubrication to this kind of a system. So, okay, there we go. There we go. Okay, moving on. So let's just put that back on there in its proper place. It's really hard to tell, but if you can, before you tighten it all the way down, try to adjust. Try to adjust where the spoon switch is going to make contact. With the pop bumper post that's coming through the playfield. So this one's pretty centered now. It's all snug down. I wish it were switch was a bit closer. That's what I'm trying to do here, is tweak this a little bit. So there we go. So the slightest little bit of movement on that should activate the pop bumper, closing the spoon switch there. So we're going to put this back in place, just like that. I'm just going to hold it on there just the slightest bit and position all the other things that... So the actual metal ring of the pop bumper needs to make sure you get both sides, and the hole here through the metal piece, and the little plastic bakelite piece. The switch for the scoring needs to be on the proper side of things, which it is now. Okay. And just refer to the other ones and you'll understand what I mean of the switch placements and what side it needs to be on, so things will score properly. So my next thing that I'm going to do with this machine, I'm going to, and I kind of did this out of order, but really what I should have done is do all of the ground mods and then rebuild these pop bumper driver boards. So when we go to test this, and we will here in just a moment after I get this tightened down, we also need to check the fuse, make sure it's all good. We will only test it for a few moments just to make sure that the pop bumper driver board that we just rebuilt is functioning properly, but I don't want to damage any of the new components on there as a result of the grounding mods not having been done. and have to go back and redo some of my work on those pop bumper driver boards. So we're just going to test it real quick and then call that a win. And then in the next video, I think we're going to do the grounding mods on the pop bumper driver boards. Okay, there's that. We just need to solder the leads back on here, and we will be ready to test. Well, I still have to put the driver board back in there also. So. Okay. Okay. So we know that this one here that we just redid belongs to this one here because this is our purple, purple, red on this lead here, and it goes to this right hand side, and we got our diode in there. So I'm going to put that back in, one of the new ones that we just rebuilt, such as this one right here. I'm going to put this in. It would normally, I think, go like this, and this plugs in like that. Yep, just like that. And I'm just going to let it dangle there for the moment. I have all the other pop bumper driver boards detached at this time. I'm going to turn off my soldering iron here, lower the play field, hold your hands over your ears because it's a terrible noise. Okay, we're in. I have the 3 balls here. Let's see what you guys can see here. Oh, you guys got a pretty good view. Let's lower you down there. Okay, turn on the machine real quick. Excellent. Okay, so this one here should now be functional. And it's been burnt out for so long. I have all the other boards undone, but that's one of the boards that we just finished. So that is a win. So, let's see here. Okay. Again, like I said, I don't really want to ruin anything, so I'm going to turn it back off. Our pop bumper driver board rebuild is a success, and we are going to... is that the end of the video? I think it is. Yeah, I'm going to say that's the end of the video. So we rebuilt those. We're going to, this next time, do the... anything. We're going to do the ground mods, is what we're going to do. So, check back next time for that. If you would, please like, subscribe, and check back here very soon for the next video in this video series. Appreciate you guys stopping in. Have a great day. Bye-bye.